Everybody, Mr. Bucko here with a couple of examples from section 3.4 on solving equations of the form ax plus b equals c, which is what we have right here. And this is just a general form of an algebraic equation where in this case x is our variable and then a, b, and c will be known values in an equation. So we'll do a couple of examples that look like this, and that might clear up some confusion as to what this a, b, and c is. So our first example here is negative 12x plus 2 equals 50. Here in this case negative 12 is the a, 2 is the b, 50 is the c, and that's not really of any importance really at all to know that. It's just an equation of this form. And our goal here is to solve for the variable x. Our goal is to find out what is the value of x that makes this sentence true. And we can probably look at this equation and guess numbers and do things in our head to find out what x is, and that's great, but what we want to do here is to undo the processes of the equation to find the value of x. So we're just going to use the reverse processes of the operations that are here to show that we know what the value of x is and have some argument written down as to why we are saying the value of x, what it is that we're saying. So we have negative 12x plus 2 equals 50, and we're going to kind of do the order of operations backwards here. Our goal is to isolate x. When it says solve for x, we want to get x alone. So the first thing I'm going to do here is take care of the addition and subtractions. So we're kind of going backwards in the order of operations, and I want to get rid of this plus 2. The opposite of plus 2 is minus 2. So what I'm going to do is subtract 2 on both sides. And to clear up the both sides, I'm going to draw a line down the equal sign, which is an unnecessary step once you get familiar with this, but just to separate the left side from the right side to kind of keep things a little organized. I'm going to draw this line here. And then I'm going to add negative 2 on the left-hand side, add negative 2 on the right-hand side. This is where this line comes in handy so that we can see that I'm doing it to the left side and I'm also doing it to the right side. And then we combine like terms and we get an equivalent equation. We get negative 12x. Notice there's nothing here because the 2's are gone. And then we get a 48 because 50 plus negative 2 is 48. And these two equations here are called equivalent equations because even though they look different, the value of x is still the same thing. Whatever x is here, it's the same thing here. So we have negative 12x equals 48, and we have negative 12 times x, so we are going to divide by negative 12 to get rid of that negative 12, because that's the opposite of multiplication. And negative 12 divided by negative 12 is 1, so we'll have just the 1x here, and then we have 48 divided by negative 12, which is negative 4. So we are saying here that x is negative 4, and again, we may have thought that when we looked at the equation originally, but that is our answer, and here's our reasoning for why we're saying it's negative 4. If you're not so sure that's the answer, what you can do is you can go in and you can check. Does negative 12 times negative 4 plus 2 equal 50? Well, negative 12 times negative 4 is 48, and 48 plus 2, is that 50? It's off the screen there, but 50 does indeed equal 50. So we've checked that our answer that we got does indeed work. Another example, example 2 over here. We have negative 4 plus 5/6y plus negative 2 equals negative 31. When I look at this equation, I see something that I can do, and I'm going to write this equation here. 5/6y plus negative 6 equals negative 31. I didn't do anything to both sides there, but I have a negative 6 here, and that negative 6 comes from combining the terms of negative 4 and negative 2. Negative 4 plus negative 2 is negative 6. So I've just kind of simplified that equation a little bit to make things a little bit easier. Now we're in a position right where we were with the start of this equation here. We have an equation of the form ax plus b equals c. It's this two-step equation. I have a plus negative 6 or a minus 6. Plus negative is the same as minus, and the opposite of minus is plus. So what I'm going to do to both sides here, once I separate my left side from my right side, is I'm going to add 6, because that will eliminate this negative 6 here, and then we add 6 to the right hand side. When we do that, we get 5y equals negative 25. The 5y is from right here, nothing happened to that, but the 6's are gone, which is what the purpose of adding 6 was, and a negative 25 from negative 31 plus 6. Now we want to get rid of this 5/6 times y, so we would divide by 5/6, but dividing by a fraction is not the easiest thing to do, but our algorithm for that is to multiply by the reciprocal. So we're going to multiply both sides of the equation by the reciprocal. And even though this looks like a mess here, 6/5 times 5/6, That's 1, because we get 30 over 30 is 1. So we're left with the 1y. And on the left-hand side, we have negative 25 times 6/5. That's like negative 25 over 1 times 6/5, which will give us y equals negative 150 over 5. And negative 150 over 5 is negative 30. So our value for y in this equation is negative 30. And that's one we probably wouldn't know by looking at it. I don't think that we could really look at this one and say, I think it's negative 30 or negative 20 or 10. It would be hard to kind of do this one in your mind, which is where these inverse processes here come in pretty handy. So y is negative 30 in this case. And one more. We have an area of a rectangle of 78 centimeters squared. What's the value of n? Well, we know that to find the value or the area of a rectangle, we do the width times the length, or the base times the height. There's a couple different ways you can say that. It's basically taking this dimension times this dimension. So we're going to get the area, which is 78. We know that because we're told that it's 78 equals 6, which is we're calling the width here, times the length, which is 2n plus 1 here. And notice here we can't do 2n plus 1, so we're going to have to use the distributive property, multiply 6 times 2n and 6 times 1. And upon doing that, we get 78 equals 12n plus 6. And here we are again, back with a two-step equation. We want to solve for n, so we're going to, again, separate the left side from the right side. We're going to subtract 6 on each side and get 72 equals 12n. We're going to divide both sides by 12, and we're going to get 6 equals n, because 72 divided by 12 is equal to n. And there we have solving a couple of two-step equations.